Lesson 1.7, Functions. First, the definition. A function is a type of relation where the x-coordinates do not repeat. So the y's can repeat, but not the x's. The second definition is a relationship between input and output, x being the input, where there's only one output for each input. So every time you put in an x, there's only one possible output or answer for plugging in that x. Now in example 1, we have 4 relations, 2 tables, and 2 mappings. Our job is to determine which of these are functions. So what we're looking for is, do the x's repeat? If you notice, this is a 7, 4, 2, 5. Those are all 4 different numbers. And since they are all different numbers, this is a function. Now in example B, -2, 0, 3, and 4. All 4 completely different numbers. So this relation is also a function. In C, you'll notice that there is a 1 at the very top of the table and a 1 at the bottom of the table. This tells me this is not a function. I cannot repeat the x's. And lastly, -2, 0, 2, and 4. Those are all completely different numbers, so this is a function. So as long as there's no repeating, it's a function. All right, next one. Okay, the vertical line test is another way to test if a relation is a function. What you do is you draw a vertical line, and if the vertical line intersects the relation or the graph more than once, then it is not a function. So we'll start with the first one here. If you notice, the red line is the vertical line. How many places does the red line intersect the green line? Only once. So that means it's a function. Now, if I draw a vertical line in the second one, you'll notice that they intersect in 2 places. This tells me it is not a function. In the third one, the vertical line only intersects 1 time, so this is a function. In the fourth one, I hit that 1 green dot. I hit that 1 green dot. I hit 1 green dot. I hit 1 green dot. No matter where I place it, I only hit 1 green dot. So that means that the fourth one is also a function. And the final one. One green dot, 1 green dot, 2 green dots. If I hit 2 green dots, then it is not a function. If you hit the graph more than once, it is not a function. Now the last example on this page is listing a relation as ordered pairs. So look at those 4 ordered pairs and determine if those 4 ordered pairs make a function. Okay, so 3, 5, -5, -2. Those are all different numbers, so this is a function. Now that goes over the 2 ways to determine something is a function. You look to see if the x's repeat, Or you do the vertical line test to see if the graph is intersected more than once. More than once is like if it was repeating an x. All right, so hopefully you can determine functions. Now, in examples 3 and 4, we're going to talk about function notation. Function notation uses this x with a parenthesis around it with an f in front. Now in example number 1, or example number 3, the first one on this page, we want to take -2 and replace it for x. So that means I want to take f of x, which is -5x plus 25, and determine f of -2. Now don't do anything with the -2 and the f. That's just telling you what number I'm putting in the problem. It doesn't require any work. Instead, do the work over here on the right. Replace the x with a -2 and then multiply that times the -5. So, -5 times -10, or sorry, -5 times -2 is +10. Add that to the 25, and I'll get 35. So f of -2 is equal to 35. That's your answer. And for example 4, you're going to do the same thing, except this time it's not function f, it's function g. If we have more than one function on a page, we're going to probably use different letters so that you can tell them apart. So this time, I'm going to put 3 in for x in function g. So g of 3. So everywhere there's an x in the problem, I'm going to put a 3. Now that I've changed the x into a 3, you should do order of operations and work that out. You should take a moment to pause and try that. Okay, so hopefully you did not do 4 times 3 and get 12. Hopefully you did 3 times 3 because exponents go before multiplication in the order of operations. So it's 3 times 3 makes 9. From there, we do 4 times 9, which is 36, plus 2 equals 38. So g of 3 equals 38. And that's the answer to your problem. All right, I've got a few examples on the last page for you to try. Okay, go ahead and plug in 4 into function f, and then plug in -5 into function f. When you're finished with that, move on to the second function g, substitute in a 3, and lastly substitute in a 2z. Go ahead and try these problems now. All right, let's take a look and see how you did. In the first one, I'm going to put, after the 3, a 4. Now I'm going to multiply that together. 3 times 4 is 12. 12 minus 4 is 8. So f of 4 is 8. That's my answer. Now over here, I'm going to put a -5 in. So after the 3, we'll go a -5. I'm going to multiply again. 3 times -5 is -15. -15 minus 4 is -19. So f of -5 is -19. Now for g, which is a little bit bigger function. 1,248 minus 160, and then that's where an x comes, so I'm going to put a 3, plus 16, there's an x, 3 squared. So the 1,248 doesn't change. 3 times 160, I think that's negative 480. Now don't times by 16. Make 3 squared 9. And then you still need to do one more multiplication. 16 times 9 is 144. Now you can do all the subtraction and multiplication. Plus 144, 912. So G of 3 is 912. So I'm going to put 2z behind the 160, and then I'm going to put 2z where the squared is. Now 1,248 doesn't change. 2 times 160 is 320, and then there's a z after that. If you square 2z, you have to square the 4 and the 2, and that makes it a 4. And then z squared is z squared. And then times that 4 by the 16, and that makes 64 z squared. And since all of these are different terms, you have no like terms. So this is the answer. 1,248 minus 320z plus 64z squared. Z squared, z, and the one without a z are different. And that would be the final answer. All right, I hope this explains functions.